Welcome to the lesson on powder metallurgy. Upon completing this lesson, learners will be able to define powder metallurgy and its key steps, including powder production, compaction, and sintering. Learners will also analyze the advantages and disadvantages of powder metallurgy and identify examples of parts commonly produced using this process. If you have had a chance to play in the snow in the winter, you most likely have made snowballs or a snowman. To make a snowball, you have to collect a handful of snow powder and compress it in your hands to create a more solid ball. The process of making snowballs is similar in concept to the process of powder metallurgy. Powder metallurgy is the process of compressing and heating metal powder in a controlled atmosphere to produce a product with the desired shape and properties. The metallurgy process produces products like bearings, filters, and flow regulators. Products required for specific applications can be produced economically using powder metallurgy because no excess materials need to be removed after the product is formed. The four basic steps in powder metallurgy include powdering, blending or mixing, compacting or pressing, and sintering, also known as heating. We will discuss these steps in the upcoming slides. Based on the specifications, powdering takes place when the required metals are converted to powders using the process known as atomization. In atomization, a liquid metal is fragmented into molten droplets. The molten droplets are then cooled down through solidification to produce particles. Powders of aluminum, copper, steel, and various alloys are made using this process. Once the metals are powdered, they are mixed together so that the final product has the desired properties. The mixing process is also known as blending. The final product is a mixture of various sizes and grades of powders, along with certain binders and lubricants so that the required chemical, as well as physical properties, are obtained. Binders are used to bind the various types of particles and are often removed once the final product is completed. The blend powders are compressed and pressed into the required shape to acquire the desired strength and compactness. Compacting is done using mechanical presses and other similar rigid tools. Other metal forming processes like rolling, forging, and extrusion discussed earlier can also be used in compacting. After the compacting process is completed, pressed power products are heated in a controlled temperature atmosphere, and this step is known as sintering. The temperature in the sintering process is controlled so that it does not rise above the melting point of the metal that is being heated. If the product contains impurities, then those impurities are evaporated during this process. This evaporation may result in porosity or permeability of the powdered products. The main advantages of the powder metallurgy process include the manufacturing of complex shapes, helping with the reduction of scrap or waste, and providing flexibility in the properties of materials. These processes help to increase production rates because they are simple and readily automated. The main disadvantages include high material costs, high tool costs, and other health and general safety hazards due to the atomization processes. Here are some of the components in electric vehicles manufactured using powder metallurgy techniques. The motor assembly produces stators and rotor cores to achieve optimal magnetic properties, while permanent magnet materials are manufactured to provide the necessary magnetic field strength. The method also creates motor shaft bearings and bushes, often incorporating self-lubricating properties for better performance. Heat sink materials produced through powder metallurgy help manage thermal conditions in various EV systems. The process is valuable in creating transmission gears that require high precision and durability. Powder forged connecting rods are manufactured to withstand the high stresses in the powertrain system. Sintered washers, which are self-lubricated, are produced through this method to provide reliable performance in various mechanical assemblies throughout the vehicle. In summary, powder metallurgy involves compressing metal powders to produce parts with specific shapes and properties under controlled conditions. The process consists of four basic steps: powdering, blending, compacting, and sintering. One of the primary benefits of this manufacturing method is its ability to create products with precise shapes and tailored material properties while minimizing material waste. However, the major drawback of powder metallurgy is the significant investment required for materials and tooling. Thank you.